Hello everyone. Next program is based on binary search using one-dimensional array. The title of the program is to design and develop a C program to perform binary search using user-defined functions. The description of the problem is the program should prompt the user to enter input elements into one-dimensional array and a target value to be searched within the array. So the user will be providing two input values. One is the array and second is the target value which he wants to search. The method is use one-dimensional array to store the integer values. Also use functions to implement the logic of binary search by passing reference. So you're supposed to use functions for implementing binary search. Let's have a look at the syntax. To initialize and to declare an array, one-dimensional array, this is the syntax to be followed. It uses three elements: data type, name of the array, followed by size of the array. This is the example. So these are the input values which will be provided by the user, the element which is to be searched, the array, along with the size of the array. These are the values provided by the user. This is the key which is to be searched. So the output of your program will be if element 14 is present in the array, you have to display the message element is found and also display at which position it was found. Because the counting of the array begins from 0, the element is found at position 3. In this array, it is found at position 3, but the count begins from 0. So it is actually at position 4. 1, 2, 3, and 4. So element is found at position 4. That is what the output should be. Now let's start writing the program. I'm using Dave C++. We will start off with hash include stdio.h. This is the standard input output file, header file. Because you have to use function, let's declare a function. I'll call it as int binary, or let's call it binary search, which takes three input values. First is the size, second is the array, and third will be the key which is to be searched. So these three values will be provided by the main program. Let's start with void main. Now in void main, you are going to take the array, the key value, and the size of the array as input from the user. So declarations, my array, I'm assuming maximum size of 20, but the user will be providing the size. I will be taking a key element from the user. Other variables, we can declare it later. Now, start taking the input from the user, enter size of array, scanf, %d. The size will be stored in a variable, let's say n. So I will declare the variable here n. Once the size has been taken, the next step is to enter the values. Enter the values of array. Now please remember, in binary search, the values of array should be in sorted order. Only then you can perform binary search. So let's mention here, enter the values of array in sorted order. This is very important. If the array is not sorted, you will have to sort it first and then perform binary search. Scanf. Now, because it's an array, one-dimensional array, you can't write scanf directly. You need to put it inside a for loop. So for, I'm going to use variable I. For I is equal to 0, starting from 0, I less than n, because n is the size of the array given by the user, I plus plus. Here I'll be putting my scanf statement. percentage %d, and this will be stored in A of I. So the first element goes in A of 0, second element A of 1, A of 2, and so on. Values have been taken. Now let's print the values and see whether it has been correctly stored in the array or not. So next is printf values of array are, remember this is only printing the array. Now because I want to print it again, I have to use for loop starting from 0 up till value n. So for loop, instead of scanf, I'm going to write printf. And let's remove ampersand sign and I'll put \d. New line everywhere you can add if you want to. Okay. The values have been read, the values have been printed on screen. Now the next step is giving a call to the function. So let's take a variable. I'll declare it here. Let's say there is a variable called result. So result is equal to giving a call to binary search function, binary search. These are the three values that it takes. Okay. So binary search, you have the size stored in n. Then you have the array A of, we will just be passing the name of the array, followed by the key. Key is the value which is to be searched. Well, we haven't taken it. Let's take the value of the key also over here. Once the array has been taken, your next statement would be to take the key element which is to be searched. Enter the key element, or you can say enter the value to be searched, and we will store this value in a variable called key. So I have taken the size here, size of the array. Then I have taken the array values over here. And third input, I have taken the key over here. These statements are only displaying the value of the array on screen. Now I'm giving a call to the function. So this is called as function call. Calling the function with three values. Remember, whenever you're passing an array to a function as a parameter, you will only pass the name of the array, not the square brackets, just the name. So the name of the array is A. I will only be passing the name of the array A. Okay. Let's write the function now. Later we'll come back to this part and complete it. Now I'll be starting with the function. So this is the function declaration. I'll use the same thing and paste it here as my function definition. Make sure you have to remove the semicolon when you are writing function definition. And this part is called as function declaration. Okay, let's start with implementing the logic of binary search. Okay, the logic is you have the variable low and high. Again, mid. Low should be initialized to 0 and high will be initialized to n minus 1. These are the two initializations that you need to make before you start with the logic. Then you have a while loop. While low is less than or equal to high. This loop will run till low moves or reaches the position of high. If it goes beyond high value, the loop will stop. This is the condition of the loop. The first thing that you should do is calculate the average. Mid is equal to low plus high, the whole thing divided by 2. Once you have calculated the mid, then you need to check, is your key element equal to A of mid? That means, is the key that you're looking for found at position A of mid? If yes, then no need to check further. You can just let's take one variable using return statement. You can return mid value. If the key has been found, then you are returning the value of that position where it was found. That is in mid. If the key is not found at this position, then you need to shift the arrows of low and high. So we have one more if statement. If A of mid is less than the key value, that means your key is greater than the middle position. In that case, your search area will be the higher side. So in this case, you will move your variable low, you will move low to mid plus 1 because as I said, the search area is towards the right. So move the low arrow. Else, if the search area is not the right towards the right hand side, but it is towards the left hand side, less than the middle value, then in that case, you should shift your high variable to mid minus 1. If none of these elements have been found, okay, if the key is not found, in spite of shifting the mid, the low and high, still the element has not been found, then in that case, we are going to write one return value. Let's say return minus 1. So it is going to return minus 1 when the entire array has been searched, but still the key element is not found. Then in that case, it will return minus 1. Now, after execution of binary search, the call will again come back here. So what value are you returning? That you need to print on screen. If the element is found, then you are returning the mid value. If the element is not found, then you are returning minus 1 value. So based on this, we are going to write the final answer of main function over here. If result is equal to minus 1. If it is minus 1 means the element was not found. So printf element is not present. I'll be using escape sequence \n over here. Else, if the result is not minus 1, that means the result is some value. It has been found. So in that case, else I'll write printf element is present at position %d. Now, what is this %d? The value will be returned to variable result. So mid value is returned to variable result and plus 1 because the counting of array begins from 0. That is why we are adding plus 1 here. This completes the program. So you have your the main program here, which is giving a call to function binary search. And then you have the binary search function definition over here. Let's compile this. Okay, run it. It is asking for the size of array. Let's say the size is 5. Enter the values in sorted order. The values are 11, 12, 13, 14, 15. Which is the value to be searched? Let's say 14. The values of array are 11, 12, 13, 14, 15. It is displaying the values and the element is present at position 4. Let's check. 11 is position 0, 1, 2, and 3. Because we are counting from 0, the position is 3. But for the user, it will be 1, 2, 3, and 4. So it is found at the element is found at position 4. Now let's have a look at the working of this binary search. You can try out with different values. Let's see the working. This is my array 11, 12, 13, 14, 15. This is the index position starting from 0, 1, 2, 3, 4. The size of this array is 5 and the key that I'm searching for is 14. The first step, initialize low to position 0 and high will be position n minus 1. 5 minus 1 is 4. Now calculate mid. Mid is equal to low plus high by 2. So value is 0 plus 4 divide by 2. Answer is 2. So this is the low. At position 2, I have mid. At position n minus 1, I have high. This is my middle value. Let's highlight it. Okay. Now you have to check. I'm searching for element 14. So is A of mid equal to 14? So is 13 equal to 14? No. So we are checking for is the key equal to A of mid? So the answer is no, 13. 13 is not the key that I'm looking for. The key is 14. So now you check, is 14 lying towards the right hand side? That means, is 14 lying on the right hand side or is 14 lying on the left hand side of mid? Well, 14 is greater than 13, so 14 lies towards the right hand side. High will remain as it is. I have to bring my low on the other side. So here I'll be shifting low is equal to mid plus 1. Mid plus 1. Mid is 2. 2 plus 1 is 3. So I'll be shifting. In the next step, I'll be moving. Sorry, take this. In the next step, this is my, this no longer is my low because I'm moving the low variable. This is mid. Low is mid plus 1. 2 plus 1 is 3. So this will be low and this will be high. So now my search area is only this region. Okay. Now again you need to calculate mid. Initially mid was position 2. Again we'll be calculating mid. This time low is 3 and high is 4. 3 plus 4. 3 plus 4. The whole thing divided by 2. The answer comes to 3.5, but we'll only be considering integer values. So the answer is 3. Now, in this case, your mid has been shifted to position 3. So my low is at position 3. My mid is also at position 3. I'll highlight this. And my high is at position n minus 1, which is 4. Now you check, is 14 equal to A of mid? A of mid is position 3 and 14 is the key that you're looking for. So yes, this is the key element which has been found. Now identify the position. It has been found at A of mid. Mid value is 3. But this, if you count, it's actually the fourth element. That is why while printing, we will say element is found at position mid plus 1, which is 4. Since the element has been found, no need to check further. We can stop the loop here. You can break out of the loop. I hope you all must have understood how binary search works. Thank you. Do try out for different values. Try out for elements which are present in element and try searching for elements which are not present in the array and see what is the answer that you're getting. Thank you.